Hey everyone, welcome to Live App Review. My name is Matt Lockyer with Near Protocol. So today I'd like to do a follow-up to one of the live app reviews that we did. I believe it was number 5. And in number 5, we made a payments API, but we did it without using any contracts. So we basically did this entirely on the server side, and we used, I believe, a deterministic way of creating accounts that it's all right here that allows you to store a deposit on behalf of a user by creating a special key and an implicit account for that key that was a combination of a master key's secret key plus a username plus a tournament ID. So, for example, if we were taking payments from esports players to enter a tournament, this payments API, which is entirely done server side and with no contract, would allow players to send their funds to a unique address. But we do not need to manage keys for the unique address because every key that is the secret key for each of the unique addresses is simply a combination of one secret key for one master secret key for all these accounts combined with the user ID and the tournament ID. So that's a quick recap. So we're going to do the exact same payments API, but we're going to do it with contracts instead. So I'm going to go back to Near Apps here, and I'm going to start with my boilerplate. So this would be the purpose of these tutorials is to maybe get you to follow along, so you can maybe follow along with this one. I'm just going to clone this repo, and we're going to start from scratch. So here I am in my Near Apps folder, and I'm going to clone the repository into I'll call it Payment API Contract. Or let's call it payment contract. So we'll do some fun stuff with payment contracts. We'll take deposits, etc., etc. So I'm going to go to my smart contract here. And the original Near boilerplate example is sort of like a kind of a fake minimal NFT example, but it has this struct here for the NFT. But I'm going to go ahead and get rid of that because all we're going to be doing is handling balances of Near funds. So what I'm going to do is I'm going to import the balance type. This is just a wrapper around the uint 128. I'm going to change this to, I'll just call it like deposits or something. Actually, this is a good point. I may need some information about the deposit. So I'm actually going to go back, and I'm going to keep this struct here, and I'm going to actually call this a deposit, and I'm going to keep track of the, I don't need to keep track of the owner because this map is going to map, I'll show you why here. Deposit, deposits. Okay, so all our deposits are basically going to follow this, this format. So I'm just going to put a memo field. So we'll try to make it like traditional accounting style, whatever. I don't know why I'm storing U128 in here. I'm going to flip it to balance. Now U128 is a type that helps us go in and out of like big numbers using JSON. So these come in as strings, and then we can convert them into balance. So the JSON type helps us go into and from the balance type, the U128 that is under the hood. Okay, so I'm going to call this payment contract. Okay, payment contract. So we're going to take deposits. We're going to need to have a memo field, and we have an account ID already. So remember in the previous example, we needed to keep track of a username and a tournament ID. In this example, we're going to assume that every user has a Near wallet, so their account ID is going to be available to us. So there's no real sense to keep track of the deposit based on the owner. There is one other issue here. This would only let us have one deposit per account at any given time. So one deposit per one event. So let me think here. Yeah, we probably want to do something else. We're probably going to actually have to treat each deposit like an NFT. So let me think about this. I'm going to put an owner here. And then I'm going to put I'll just declare this as a type here. Oops. I think that's gonna work. Anyway, we're gonna keep track of deposit IDs here. So pub. We're just gonna keep track like an NFT. So basically, the reason we're doing this is so that we can have a user. Oops. Oh, that's right. We can have a user that comes and makes multiple deposits. And then how do we find out all of the deposits for a particular user? Well, we are going to need, it's not a mapping. It's going to have to be a like a vector of account to Hey, that's a good question, actually. Now I'm stuck in the logic here. So I'm going to take a quick look at one of the other examples that we just did. I want to have a look at this contract because we did have token to token data. Ah, interesting. So we didn't have a way to enumerate all of the in the previous NFT example that I did for Live App Review 6 about NFTs and progressive onboarding, we didn't have a way to enumerate all of an account's tokens. So what we're going to do in order to do that is, I believe we're just going to have to do a vec here of type deposit. I think actually we can get away with this. I don't want to complicate it. So here's all the deposits, and it's just going to be a vector of deposits, and we're just going to look that up for every account ID. I think that should be fine. We're not going to keep track of the deposit ID or ID deposits or anything like that. So I think that's okay. I'm just going to double check. Looks good. All right. So you can accomplish quite a bit with these unordered maps. So all we need to do is really have a payable deposit function here. It's going to take some deposit. It's going to return, maybe it doesn't return anything for now. We're going to wipe this out. Well, I'm going to get this signer account ID. Get there somewhere from somewhere else. So let account ID equals. Okay, so now we have that information. We haven't finished the method here. We're going to do a get deposits. Now is that's JSON serializable thanks to Serde. Okay, so what I was doing is I was just checking the type up here. Sure that this can be serialized. Deposits. It's probably going to be really simple. So we'll just say I think we can just do, I prefer not to panic, but that's I think I can do something like that. We'll see. It'll probably complain. Okay, so we'll let you look up any account ID. Account ID. So this is if a wallet is signed, or anyone can look at any wallet's deposits. And then if you are signed in and you make a deposit, you can do the following. Okay, so you can you have to go get the deposits. Can't remember the VEC stuff. I know that sounds weird. Here. Right in front of your face. Okay, VEC push. All right. So this is a deposit, and we're going to have memo and an amount. So memo, change that to be amount. Memo, amount, trailing comma. Why not? We also probably, I've never done this before, but I want to find out how to do this. So I'm going to say, I think it's, I want to make sure it's less than. Why is it completing that? Oh, weird. Okay, length of memo is less than, I don't even know if that's how you do it. That might be Golang. Less than like 64 characters or something. I don't know. Keep the contract storage small. We will panic there and stop. So I really don't remember how to get the length of a string. .len. That was Golang. Memo. Okay, so we want that to be less than 64, otherwise the memo's too long. Otherwise, we will make a deposit by pushing to deposits. Okay, so that has to be mutable. And we will insert into deposits. At account ID. I don't know why that's there. Don't need. Okay, so that should allow us to make a deposit, and I think we can safely assume we can do a unit test here. Steal this test here with the purchase because it already attaches some funds. Get rid of these ones for a sec. I'll just comment them. So let's take this purchase. So don't need to set that. Let's get the contract here. Payment contract. New. Okay. Context ID. Contract. I'm not going to get anything back. Going to make a deposit. And we already have attached near to Dr. 1 deposit. So we're just going to deposit one with a memo of take my money. All right, we're going to take my money. And we're just going to get rid of that for a sec. Let's just see if it compiles. I'm not the Rust expert, so whoops. First, we have to cd into the directory. So what do we call this? We call this payment contract yarn test unit. Okay, so I'm not a Rust pro, but so I might have to do some debugging here. But what we got is we got a deposit contract that will take deposits and store them with memos and the amount. And then we can get all the deposits for an account. And then the last thing to do before we get through this is, I guess, for the user to be able to withdraw their deposit, or, you know, let's add sort of another layer of logic. So let's think that this payment contract is like an escrow contract. It will allow them to delete their deposit, which would basically mean that the funds would be in the contract forever. So it's like they've paid the organization and they can't take it back anymore. So let's look at this. Oh, it's deposits. Self deposits. Deposits. All right. And I think that was a lot of it. So now we need to pass in the reference deposits here. Okay. Some warnings there. Oh, okay, so we made a deposit. So let's get deposits. Current account ID is the signer, so we'll get the deposits for that person. Oh, I did something stupid. I went and got rid of all my assertion stuff in my tests. There. All right. Let's just assert that the length of the deposits array is correct. I don't think, well, we could go into each one of them if we want. We can like slice it open. So let's say that deposits, I think, no, I think we have to do get at 0 unwrap. I don't know if you have to do this, but if we unwrap and then we get the memo field, should be able to compare it to this string and assert that they equal each other. Oh, me and my semicolons. All right. Can't call unwrap on a none value. Okay. First, I want to know what deposits is spitting back. Deposits. Okay. So what we're going to want to do is we're going to want to print deposits. Oh, whoops. Oh, all this Rust syntax is so verbose. All right. Better not get the Rust gang after me. Could be bad. Oh, it's probably because the current account ID is different than the signer account ID? Yeah. Okay, these were different people, so let's go with that. We need to get the deposits for the signer account ID. So the current account ID is different than the signer account ID. Whatever. Who cares? I think they're just different people. All right, so we passed the test. We got the deposit. So now let's add another change method. So we'll just label these view methods. Let's add another change method, and let's call this, make payment. Now, make payment is going to be a little counterintuitive. It's basically going to specify, and here we'll have to specify like an index, deposit index. So ooh, this is going to be a weird Rust type one. It is not going to like my vector index. I think it's called usize. Let's see. This isn't going to beautifully, but this will be fun. So, and then I have to figure out vector stuff. So I have to figure out deposits. I do not know all this vector stuff. So slicing. There it is. No, that's not. Slicing is something different. So we just need remove. It's here. Move. Index usize. Deprecate. Remove. Okay. Interesting. Deposits dot remove at some usize, so we're going to call that deposit index. Now, what to do if there is no deposit there? What to do? What is it going to do? Panic if index out of bounds. Let's just leave it. Who cares? Oh, everybody else is going to love this. Everybody from the near team. Okay, so we have done this make a payment thing. We're going to get rid of that. We need to get rid of that. We have the account ID, and let's get rid of that comment. So what this is going to do is this is going to delete the deposit that we've made, and that means that the funds that were transferred to the contract are now going to be stuck in the contract. And the last thing we're going to do is we're going to make a withdrawal. So I'm not going to do like super verbose naming. I don't really want. So we are going to, if we do a remove, do we get the deposit? Removes and returns the element. Okay. Cool. And then we should, first we update the contract state, then we make a promise. Okay, we have to dig, I have to dig for a payment example. So look at progressive onboarding. That. It is the account ID, and we are going to transfer the deposit amount. Okay, so we've removed the deposit. So again, we're going to remove the deposit just like we did before. And we are going to update the deposits array just like we did before. And then we are going to transfer the amount to the new owner. We need to return the promise? Probably not. Okay. So we've got all those imported. So we have make payment now and withdraw. So make payment just removes, and withdraw actually removes but transfers the funds from the smart contract back. Now, there could be a problem. No, because it will panic if the deposit doesn't exist. Then if the deposit doesn't exist, then the user shouldn't be able to transfer the funds. So it looks okay to me. So let's do another one. Let's make deposit and payment. So we should have make payment. The deposit index is going to be 0. And then this deposit's length 0. Deposits dot len equals 0. We're almost done with the contract now. Let's just test those units. Okay, that looks good. And then let's go to the next one. Make deposit and withdrawal. I'm not going to bother checking balances or anything like that. Just check that the structure is right. Like, so the data structure, like in, out, just make sure that this is correct. I mean, it should be. It's exactly the same code. Okay, so that's our contract. That's our payments API. We can make deposits as a user. We can find out information about the deposit as any user using this view method. We, as a user, we can make a payment, which would delete the deposit here. I guess the data is being deleted, so you would need like an indexer. Let's do this, actually. Let's change it. I don't know. Is it just Boolean? I don't know. This is going to be really embarrassing, but I don't know. I didn't even know what it's called. Bool. Okay. I thought so, but I didn't know. So is it paid? So let's make it so that the user has a chance to decide whether they want to pay it. And maybe, can we edit this directly? I don't know. That's a good question. We'll find out. I redo test. We're not going to remove it. Length thing is going to. This is deposits. I'm just going to see if I can do 2. I think that's right. Okay, it's right. So, and you can do that cool, just access it. And mutate it with the array syntax there. Okay, cool. Okay, I'm satisfied. All right, so we can pay these. And let's go and do some app tests. So again, next logical flow here is to test the contract with the app. But before we do that, let's not forget to update our contract methods. So deposit, make payment, withdraw. All right. Get deposit, deposits for an account. So we get all the deposits. Yep, okay. Save that and deploy the contract. And once again, we're just gonna do just like we did in Live App Review 7, we're gonna do just one contract. So all we have to do is get contract Alice. So we'll actually just call that contract. Okay. And memo's hello world, contract. So we're going to deposit, and we're going to have memo, and what else do we have to specify? Oh, the amount gets specified, but we don't do that in the method call, so just the memo. Okay, parse near amount, one near, big spender. Okay, and then we are going to get deposits for account ID, Alice account ID, and let's just keep the names simple here. Expect deposits. Expect the memo to equal memo. And get rid of the rest of these tests for now. And let's do a test deploy. So we've done our unit tests, and now we're moving on to a test deployment of the contract where we are going to fire our jest test. Now the contract is actually being deployed against testnet. So you'll see on the left-hand side here that, whoops, yeah, it's this one. That I mean, it's the first time, so the contract's being built, and then you'll see a near dev folder pop up here. So that's a brand new dev account. When we run yarn test deploy, we're going to create a brand new dev account. And this is because sometimes the storage for the contract, the storage that the contract stores its state in is still attached to an existing dev account, like even when you redeploy a contract on top of it. Oh, I haven't even called yarn. So sometimes the storage state, so the contract state is still on the account. So what we do when we run yarn test deploy, because we always want to test against a fresh account, is we remove the near dev folder, and then we call near dev deploy again with the near CLI. So it's near space dev dash deploy. When we call that again, we get a new dev account, and then we redeploy the contract there. Now, having redeployed the contract, I think I have to just run that again. Having redeployed the contract, as you just saw there, destroy the near dev folder, get a new one, and then redeploy the contract, we have a brand new contract to test against. And then once we've done that, we're going to deploy the WASM to testnet, actually. So this is actually live on testnet, and I haven't done, oh yay, it passed. Okay, cool. Getting better and better. So I haven't tested this actually, or I haven't shown this actually in a lot of the videos, but I do want to assure you that these are real tests going out onto our test network. So you'll see here that the anyone can do this. You know, the contracts are being deployed here, right? And anyone can just come here and see that the contract's deployed. So this is live. This is our testnet. And I'm testing against our testnet and not a local environment because our testnet is pretty fast and pretty good. And I don't mind waiting a few seconds. I mean, the total test took 12.476 seconds to fully test this contract. Well, not fully test, but to basically test the contract. So that's pretty cool. So now I'm going to check create and make payment. So this should be, by the way, this should be paid, should be false. You can add that there. And then we've already made a payment, so we can just make the payment on this one. no deposit. Okay, and then don't need to recheck the memo. And in this case, the payment is true. So there we go. Check, create, and make payment. Also want to check, create, and withdraw. So in this case, let's expect that deposit at 0 to equal, it's probably going to equal null. I'm just going to guess. Or let's do deposits dot length equals, to equal 0. Okay. Oh, we we forgot something. You can withdraw a deposit that is already paid. So we forgot to do that. Okay, that's a good one. Make a payment. So in this case, now I'm going to go back and edit the contract. I should not be able to withdraw a deposit that is paid for. So that deposit will stay in there as like record keeping until the contract owner can like clean it up for storage. But basically, I should not be able to withdraw the deposit if the deposit is paid. So we're going to panic here before we reinsert the deposits, and that means that it should just revert. It'll just ignore all this. It won't actually save the state. So we're going to check that the deposit dot paid payment was already confirmed. So the payment was already confirmed, which means paid is true. We have to make sure that the deposit paid is false when we want to withdraw. So we'll have to redeploy the contract. So check and make payment, check and withdraw. So we should, I'll just say check cannot withdraw. Withdraw. This is going to panic. So we'll do that, and then we'll catch this, and then we'll expect true. I'm just going to do this a little lazy styles. Oops. Pretty simple test here. So let's do test deploy, because this is going to deploy the contract with the edit there. So all we added was we added an assertion to make sure that paid must equal false before we pay out from the contract. And this is because the user's already confirmed that they want to make a payment. So this is a payments API. The user has deposited funds to the smart contract and then additionally confirmed that they do in fact want to pay for what the memo says, let's assume. So once they've confirmed make payment here, remember for all these tests, we're using the same contract. So once they've confirmed make payment, they cannot withdraw again. So in this case, it did panic. Let's do a console.warn here, just to make sure we don't kind of just sweep that. And let's do this. Now we're going to do one where we will create and withdraw. So we're going to make another deposit, and then we're going to withdraw at the deposit index 1. And then we're going to check all the deposits, and the length of the deposits should be 1. Because remember, we still technically have deposits made, but paid is true. And then we'll just check. Okay. So we're never going to actually we're only going to remove deposits when we withdraw. So yeah, so the length is 1. Okay. Let's go ahead and try that. We don't need to redeploy the contract, so this will be quick. This will be fast. I looked up here. It's not that fast. We should also see the warning here. Check cannot withdraw. Panic, that payment was already confirmed. Okay, that was expected. And check create and withdraw. All right, cool. So that's it. So the last thing to do, as always, in these live app reviews is to basically write the app front end. So remember, we're going to do a really quick and dirty job here on the front end. It's not going to be pretty. We're going to get rid of some of this local access key stuff. I'm going to get rid of that keys component altogether. We're going to go into the contract component, and we're going to just get rid of references here. We're going to get rid of this stuff. We're going to probably put a memo, set memo, load deposits, and we're going to do that, and we are going to get a contract just with the account. So again, if we're going to assume that in order to use this contract, we have to have a wallet that is signed in. So if there's no account, we're just going to return null from this component. Load deposits. We will just wait. We'll wait on that for a sec, and then we'll handle deposit and get rid of all that error checking stuff. Loading, get rid of that. We can bring it back if we want. And then we're going to handle payment. And we are going to handle withdraw if the user wants to withdraw their funds. Okay, so now we are going to crop all of this down and go to a very minimal representation here. Okay, and we can just spit that out if we're signed in. So now let's start the app. Okay, all my little notes here. Okay. Building, 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 building. Save that actually. Just key. Yeah, input memo, set memo. Memo for the deposit, right? And then, oh, we need deposit amount in near. The value is going to be the amount, and we're going to set amount, and we need to parse all that when we actually go and update it. But we're just going to run with a bit of a skeleton setup for now, just to make sure everything compiles. And we're just going to say handle deposit. Handle payment, handle withdraw. So we know all of this works, right? And we know that because of our app test. So we don't really have to worry about writing new code or writing anything really, but we could actually copy paste from the app tests because they're JavaScript too. So make a deposit for the tournament. So I said we would get back to this sort of tournament entry. So assume on the back end that there's some tournament, system or whatever, and there's some prices being spit out. So you're going to make, these are not going to be enforced. They're just about the memo. So you just say, I want to go into, tournament, whoops, tournament X, and I'm going to pay 5 near, handle deposit, and that is going to, I mean, that just spits out, well, it spits out nothing right now. But that's the general idea. So we were going to go get the contract. By the way, I'm just going to sign out and sign back in again with my localhost just to make sure that I gave the right key for the right contract. The key for the app, the signed in key, gets stored in localhost, but I just booted up a brand new app, so I'm assuming the contracts are different. So I'm going to go get the contract. Oh, all these pop-ups, got to disable them. So then I'm going to await contract.deposit. Oops. Oh no, whoops, that is going to go on to the end there. So it's going to be gas and the amount and the memo. And we don't need anything there. Okay, and then after we do that and we wait for that, we're going to load deposits. Okay, then we're going to handle payment, make payment. And which deposit do we want to make a payment for? Deposit index. This is a little weird. It's a little contrived because we don't actually have the deposits listed. So what I'm going to do is I'm going to, in a little bit of anticipation here, deposits, set deposits, excuse me. And, oh, we haven't even gotten the deposits, so set deposits is going to be okay. So we're going to get the deposits and set them for the local state. And then we're going to, for each deposit, we're going to spit them out. Y'all ready? Y'all ready for this? This is just, you know, front end sugar. Let's put it all in a p tag. I don't care if it complains. It's gonna complain. Something like that. Okay, so now we can make these payments, but we should pass in the deposit index. So we haven't manipulated the array. This is a little bit shaky ground. Like the array's order could change or something like that, but we haven't done anything. We just pulled it and we showed it. And so we'll let you do stuff like this. So you're gonna make a payment. Let's just call that deposit index. It'll make our life easier. Make a payment. Don't add a deposit to that. Then load deposits again. Same thing here. The reason I keep getting a contract instance is because sometimes I switch users, or I have this like tendency to, you know, maybe switch the signer if I'm making an app with like a guest account or like an access key. So that's just why I get the contract instance every time. Doesn't really. We're gonna withdraw in this case. Here, actually. This is really terrible error handling, but I'm just gonna, you know, alert Um, okay. So there's obviously no deposit, so we don't need to do anything fancy with that. Let's see. All right, so the contract is now requesting a transfer of 5 near, so I'm transferring 5 near to the contract. I hope it makes a payment. Ooh, look at this. Oh, and I got back a really nice value there, and I got back nothing for paid. So obviously there's some issues here. Okay, I know the first issue. So the amount needs to be U128. And then when we withdraw, we have to take that into account. Gotta love this Rust stuff, huh? It hates it. I just gotta make sure it comes back as the right amount. Expected blah, blah, blah. Blah, 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 blah. So this is the difference between the balance type, which is U128, and this U128 type. I don't know. So I'm just gonna call it, all you gotta do is just call it into. Into solves everything. All right. That looks like it worked. We're gonna need to redeploy the app anyway. Our app test never checked the amounts, so it should be okay. It's not gonna complain. The test should pass. And then we're gonna have to reboot the app. Taking a while. Okay, so we're going to reboot the app, and hopefully the amount that comes back is going to be something that we can work with, which should be a long string and not this. The problem is we had this crazy scientific notation before. I'll have to move this field. So there's the memo. There's 5 near, and you notice I'm just. Oh, whoops! I better sign out and sign back in again. I'm just losing near, but it's testnet, so who cares? And the other contract's gone. So be careful on mainnet. So here's the memo for the payment, and here's 5 near. Make a deposit. Allow. I should have some sort of meaningful amount here. Okay, and now we want to show that. So and paid's an interesting one. I don't know why it's not showing up. But if it's undefined, then what we're gonna do is we're gonna do one of these. Okay, so paid is false. Handle payment, so that has the index, and it's going to come up here. The index is 0 according to React and according to the deposit array. I'm going to come up here and make a payment, and then I should not be able to withdraw. So handle payment. I should see it go true. Okay. I don't know what's going on now. Let's do one of these. Okay, we'll go with that. A little bit hacky. Handle withdrawal. So this should complain with the alert. Payment already confirmed. Awesome. So now I'm not going to waste a bunch of near tokens. I'm just going to do some BS here, make another deposit. This is confirmed as false, so I'm going to withdraw, and I have 301. Now my balance didn't get refreshed automatically, but if I refresh, I have 302. Okay, so I got my deposit back. All right, that's it. So what have we done today? We have created a payments API for entering tournaments. That's our example, entering tournaments. But basically, it is a general payments API as a smart contract that can take deposits and attach a memo. The user making the deposits can sign in with their wallet and make a deposit. They can choose to pay the deposit, they can choose to approve the payment of the deposit. So the funds are held in escrow until they are confirmed again by the user. So that's just like a design choice. Or the user can withdraw their deposit. So the user can first indicate that I have made a deposit and I'm interested in entering this event, but for whatever reason could deposit before the event actually happens. Next time, actually, I'm going to do a mini payments API 3 where I'm going to add some timing to this. So we're going to explore subscription kind of models, but we're going to build on top of this deposit model. So the user is going to make a deposit, and then the user will start their subscription, and it will basically start ticking away. And then the user can withdraw funds and basically withdraw at any point in the time of the subscription and get back the rest of their deposit. So that should be really cool. But this is all we have for now. And yeah, once again, join us on near.ai/docs. We have an awesome new sort of doc setup here. Lots of quick starts and jumping off examples. If you hit the introduction to front end, it's been updated to give you a very quick high-level look to getting up to speed. And of course, the API library and kind of boilerplates are here to quick start with Node or the browser. So that was my contribution to the docs refresh recently. And please join our community. So click on the community channels and find us on Discord and Telegram. And please follow us on Twitter and participate in the Near Governance Forum. This is really cool. It's sort of like the place to be. Marketing, community, staking, development. Me personally, I'm under developer relations here. We're going to be adding a lot more topics of developer relations, sort of subject material that we'd like to see from the community. So just like video tutorials like this, we are asking our community to give us feedback on what you would like to see in the live app review and other examples like blockheads and live contract review. So please join us on the near.org/government forums or gov.near.org. It's awesome, and there's a lot of really nice people having a lot of great chats. Okay, until next time, we'll see you later.